Hi everyone, this is Mathematics 2 week 11 graded assignment. So our first question here is, consider the following function f of x equals to x square z plus y cube e xy plus sine xyz. Okay, so we need to check which of the following options is true. So let us start with the first one. According to first option, we need to find this. Let me just write it. Yeah, it's of f upon sigma x square. So this is what is needed to be found in first or second option, whatever is correct. So I'll start with that. First of all, the first differentiation, first order, so that would be 2xz. Because when we are taking a derivative with respect to some value like x, we take all other variables as a constant. So 2xz plus, here this would be y raised to power 4 e raised to power xy, and at last we will be having yz cos xyz. Perfect. So now we will double derivate this, so we will be getting here 2z from this, and from the second term we will be getting y raised to power 5 e raised to power xy. Here we will be getting, as we are doing with respect to x, this would be y z square into my cos, derivative of cos is minus sine x, so whatever sine theta, so we can write it like minus sine xyz. So after opening it, we can surely say that this will be equal to this goes for this, but unfortunately this is not z square, so first option will be discarded and we will go for second option here, right? This minus signs comes here, so it will be minus, right? Perfect. This was the first option, so I'll be selecting the first option here, second option here. First option is to be discarded, and in next we need to find f of zy. First we will be taking a derivative with respect to z, then y. So when we take derivative with respect to z, we will be getting x square plus, this would be 0 as there is no z term here, plus this would be cos xyz into, I'm just taking it whole, right? So this would be xy, right? Now I'll be taking a derivative with respect to y, so that would be here 0 plus this will remain 0, right? Plus this would be now minus sine xyz, and this would be y square xz, right? We will be getting on the next derivative with respect to y, we will be getting x and z, so xz into xy would be x square yz. So it seems I made a mistake here, it would be x square yz. So yeah, perfect. Basically this option is wrong, right? Instead the actual answer should have been minus sine xyz into x square yz, basically just minus sine instead of cos. Okay, so for the next option we will be seeing that and this corresponds to, first of all, take derivative of with respect to x. So again that would be 2xz plus y raised to power 4 e raised to power xy plus yz cos xyz, right? Now we will be taking with respect to z. So with respect to z, this term would be 0, right? I'll remove this, and for basically, let me just, yeah, perfect, this term would be 0, and for this we will be getting 2x, perfect. This corresponds to the option number 4, 2z, and here we will be getting, this would be the minus sin x when taken as derivative, so minus sine of x, y and z, and instead we will be getting out x, y as a constant, so this would be this multiplied by xy, so we will be getting 2z plus y square xz minus sine xyz. Awesome, it's perfect. So we can rewrite this as 2z into minus of x y square z sine xyz, right? Perfect. So seeing from our result, we can surely say that second and fourth option are correct. Perfect. Now the number of critical points in the function xyz. So first of all, we will be taking f of x, that would be wait a minute, yeah, that would be e raised to power, I think it would be better to use the UV rule here, right? So using the UV rule, we can say this is being multiplied by this whole polynomial, 3 variable polynomial, right? So it's not a polynomial, right? Sorry. So yeah, function. So e raised to power x into 2x, and the whole term would be 0. This would be 0, this would be 0, as we are differentiating with respect to x. Now that plus, now this will remain the same, x square minus y square minus 2z square into e raised to power x. I hope you agree with me on this part. First I differentiated in the bracketed terms, and then I differentiated e raised to power x, right? So the next part is we should find f of y. Now f of y would be simply ex into 2y, and again, because this would be treated as a constant, I hope you get my point here, and z would be e raised to power x to 4z, and that would be minus of that, and here also. So we can surely say that this would be equal to 0, 0 and 0 to find the number of critical points for the function. So here z will be equal to 0, we can imply that, and here also z will be equal to 0, and we need to find the intersection of all of these. So we can just put here that z is 0 in this result here, right? And from that we can say, I'll just move this because we already found out that x and y and z are 0, y equals to z equals to 0, and now f of x is equal to e raised to power x 2x plus x square plus minus of y square, which would be 0, and minus 2z square, which again would be 0. So we can surely say that f of x is equal to e raised to power x 2x plus x square, which would be equal to 0. Now here we can remove this term, and we only got two options here, that x square plus 2x is equal to 0. Either x is 0 or x is minus 2. So from this we will be getting two critical points. One would be minus 2 comma 0 comma 0. See here, x is minus 2, y is 0, and z is 0. And other point would be the origin 000, right? So here our answer would be 2. We will be getting two critical points. Now here, choose the correct statement with the following. Okay, so we can do this graphically and algebraically. Basically, if we start with an algebra sum, right? Yeah, we already know that this term here, this is like a mental ability quotient type, right? So this term will always be positive, right? And the minimum value we can get from this term would be at 0 comma 0, right? It would have been another case if there would have been some constant added to it, but here it isn't. So we can surely say that this graph would have been something like this. Certainly not differentiable at 0 comma 0, right? Because it's a sharp point there. Yeah, something like this structure. So our answer would be a global minimum of f at 0 comma 0, and we can say that this is the only critical point. We can do this by differentiation too. First of all, take a partial differentiation of this and just equate it to 0. We will be getting two values, right? So find the maximum value of the surface area of a rectangular box which has a unit volume of 1000 units. Okay, so here we can say that xyz is equal to 1000. Yeah, it's already given here. Xyz is equal to 1000, and the perimeter, or basically the function we need to find the maximum for, is 2 of xy plus yz plus zx. Perfect. So first of all, we will replace z as 1000 by xy. So I'll just remove the whole equation here and rewrite the desired form. So f of x comma y will be equal to, by replacing the z as 1000 by xy, we can write it like this: 2xy plus 1000 by x plus 1000 by y. Perfect. So all is left is to just calculate the things. First of all, we will find the gradient. Yeah, perfect. Wait a minute. Thank you for waiting. So first of all, we will be finding the gradient, as I told you guys. So to find f of x, basically, yeah, f of x, that would be 2y plus, this would be minus 2000 upon x square. Yeah, perfect. And for f of y would be, this would be 2x minus 2000 upon y square. Perfect. So, and to write them in a perfect form, we will write that the gradient of f will be equal to 2 here y minus 2000 by x square comma 2x minus 2000 by y square. And to find the critical point, we need to equate these two to 0 and 0. Basically this would be for 0 comma 0, right? So I'll just move on to the main part here. Sorry, so as I was saying that 2y is equal to 2000 when equating to 0, and 2x will be equal to 2000 y square. From this I'll suggest to remove 2 here, and this is some malfunctioning error, please sorry. So I'll just so as I was saying, I'll just remove the 2 from here. I'll just cut that. So sorry, this is happening again and again. I'll just use the notes for the better clarity, so that would be really helpful. So here, as I was saying, y equals to 1000 by x square, and x is equal to 1000 by y square. By substituting the values, we can get x is equal to 1000 by 1000 square into x raised to power 4. This will cancel out, and we will get x is equal to x raised to power 4000, right? So we will just shift the terms here, so we can say x minus x raised to power 4 by 100 is equal to 0, and from this we can say that x is either equal to 0, or we can say x is 1 minus x cube by 1000, and from this we can infer that x is equal to 10. So we get two values from here. Now while substituting, we can say that x is not equal to 0 because y would be infinity, and that would not result in a critical point here. Instead we can use x equals to 10, and from that we can certainly say that x is equal to 10 is equal to y, right? And as x equal to y equals to 10, we already found that out, so we can move on to the quotient here. Delete. We knew that x y z is equal to 1000 supposedly, so 10 into 10 into z equals to 1000, and amazingly this is also 10, and x is equal to y is equal to z equals to 10. Basically this is a cube, so we can surely say that a cube has a what was that? Yeah, perfect. So has a minimum value of the surface area. So here I will be putting 10 into 10 plus 10 into 10. I am just using this surface area formula, which was 2 into xy plus yz plus zx, 10 into 10 plus 10 into 10 whole twice. So this would be 2 into 300, which would be 600. Basically I missed a step here, which was supposed to be find out whether the given point 10 is a maxima or minima. So I skipped that because many of the people already know that in symmetry we get the minimum area, or minimum what we say is surface area in this case. So yeah, minimum perimeter for 2D dimension and minimum surface area for 3D dimensions, right? So I just used that and gave my answer here. It would be better if I explained it clearly. So but I hope you can do that on your own too. It's easy, pretty easy.